Hello, I'm Chovada. Myself, Dr. C.V. Savara. Warm welcome to Insight Education. I will teach you physics. I'm the man of physics. I love physics. I enjoy teaching physics. For most of the students, physics is the most difficult subject. But if you learn physics with me, okay, I assure you, you will love physics and your preference will change from biology to physics. Physics is again most important subject if you want to get admission in MBBS, or I can say government government medical college, because most of the students will score 300 plus in biology, 150 plus in chemistry. So for them, the difficulty is physics. Okay. So if you want to get admission in government medical college, then at least you should have more than 100 or 120 in physics. Okay. So if you learn physics with me, I assure you, you will get admission in MBBS. Okay. So today we will start with our first chapter, motion in one dimension. Okay. So why I have started motion in one dimension instead of units and dimension? Okay. So in physics, the most important thing is concept. Physics is conceptual subject. Visualization is very important. And second thing is that is problem solving technique. So in this chapter, everything you need. Theory is comparatively less, but visualization is very important. So you will learn visualization and concept, or how to clear the concept. That methodology you will learn in this chapter. Okay, again, problem solving. In this chapter, equations are very less, but how to use the equation, which equation will be applicable. So everything you have to learn in this chapter. It means if you have mastery on this chapter, okay, so you can get mastery on physics. Okay, so first we will start with chapter number 3, and that is motion in straight line. Okay, if you want to learn physics and if you want to clear your concept, okay, so always you have to start with questioning yourself. Whenever you read something, whenever you learn something, whenever you hear something new, okay, always you have to ask a question, why? Or you have to try to develop an image. Okay, so then and then you will be able to develop visualization power. Okay, similarly, suppose here, motion in straight line. So straight line easily we can understand. Okay, so now question, so what is motion? So this question should naturally arise in your mind. So now question is, what is motion? Or another way, are you in the rest position or in the motion? So at present you are listening this lecture, you are watching the video, it means you are in the rest position. Are you sure you are in the rest position? Okay. Now let me think is wrong. Just wait. Are you in the rest position or in motion? Okay, so just suppose, consider Earth, and you are sitting on the surface. Okay, so if someone is at the center and someone is watching you, so according to this person, you are in the motion. Okay, but from your side, suppose you are sitting here and your friend is nearer to you. So now, according to your friend, you are in rest position, but according to this person, you are in motion. Okay, so you may be in motion or you may be in the rest. So that depends on, so when one object changes its position with reference to another object, we say that object is in motion. So here with reference to this person, your position changes. It means you are in motion. But with reference to your friend, your position remains same. It means you are in the rest position. Okay. So motion means when object. So motion means when change in position. So now you have to develop this image. Motion means change in position. Clear? So now you can see here. Okay, so this earth rotates about its center. It means earth is in motion. Earth also rotates about the sun. It means earth is in motion. So now various types of motion. Whenever we observe in the universe, okay, we will find various types of motion, and the first one is translational motion. So translational motion, or you can say motion along the straight line. Okay, so motion along the road. So that is translation. Second, rotational motion. So that is motion around the axis. Okay, so just observe, see ahead. So motion of the fan. So that is rotational motion. Here also it's a rotational motion. The axis, you can see this is center, or you can say axis. And next is vibrational motion. Suppose we are watching the video, okay, on, suppose it, then you can say this is pendulum motion, motion of the pendulum. Okay, so if you are sitting on the swing, then your motion is vibrational motion. Okay, so there are three types of motion. Physics we can divide into five groups. First part, that is mechanics. Second, thermodynamics. Third, electrodynamics. Fourth, modern physics. And fifth, that is optics. So first we will start with the mechanics. So you can divide the mechanics into two parts, kinematics and dynamics. So whenever we describe the motion, okay, without considering the causes, then it is called kinematics. So you have read this, you have learned this definition. So it's a branch of the physics dealing with motion without considering its causes is known as kinematics. But whenever example, so whenever you solve the example, so that you have to identify these problems belongs to kinematics or these problems belongs to dynamics. So how can you recognize these problems belongs to kinematics? So for that, suppose kinematics means here we are considering the motion. Motion means we are considering various parameters like velocity, position, acceleration. Okay, so whenever you start a scooter, okay, so whenever you start a scooter, so whenever initial position, okay, initial position, you are in rest position. So with acceleration, speed increases. Okay, acceleration increases. It means here we are describing the motion, but we are not considering the cause of motion. Okay, so you have to think, suppose when we accelerate the scooter, so why speed increases? Okay, so because of acceleration, more fuel enters into the engine, and because of more burning of fuel, or because of more production of heat, or because of more conversion of heat energy into mechanical work, okay, so speed increases. It means now we are considering the causes. So whenever we consider motion along with the causes, then it is called dynamics. So it's a branch of the physics describing motion along with its causes and properties of moving body is called dynamics. And kinematics and dynamics together collectively is known as mechanics. Okay, so whenever we describe the motion, okay, whenever we consider kinematics or whenever we consider dynamics, first always we consider object as a particle. What is your weight? Maybe 75 kg. So 75 kg is a weight or mass. 75 kg is mass. Okay, suppose weight, then 750 Newton. So your weight is 750 Newton. So where it is applicable? On which body part will it work? On head, on stomach? It means it will act on center of mass. It means instead of ourselves, we have to consider ourselves as a particle and our center of mass. Okay, so force will act on center of mass. Similarly, any object we can consider as a particle. Okay, suppose when you travel from your home to inside, okay, distance may be, it may be 3 kilometer to 4 kilometer. Okay, so distance of your scooter from home to inside 4 kilometer. So scooter is a particle, or we have to consider the size of the particle or not? So no need to consider. Why? Because size of the scooter may be 2 meter. So compared to 4 kilometer or compared to 4,000 kilometer, size of the scooter is very, very small. It means we can consider object as a particle. So particle is point-like object, that object that has mass but of infinitesimal size. Size is very, very small. The smallest part of matter with zero dimension, which can be described by its mass and position, is defined as particle. So object has mass, but size is very, very small. So how can we come to know that object is in rest position or is in motion? Okay, so consider this example. Okay, consider Shah Rukh Khan is standing on the platform. Okay, so according to this Shah Rukh Khan, platform, okay, so tree is in rest position. Okay, so just train passing through the platform. Okay, so according to Shah Rukh Khan, train is in motion. Okay, तो शाहरुख खान को वहां मलिका दिखती है, तो वो जंप होके ट्रेन पे आते। अभी ट्रेन पे वो और मल्लिका क्या करेंगे? छैया छैया। ओके, सो नाउ अकॉर्डिंग टू शाहरुख खान, नाउ ट्रेन इज इन मोशन और इन रेस्ट पोजीशन। So train is in motion. Okay, so Shah Rukh Khan is on the train. It means Shah Rukh Khan is also moving along with the train. It means both are in motion, but relative velocity is 0. It means Shah Rukh Khan, according to Shah Rukh Khan, now train is in rest position. Malika is also nearer to him. There is no change in position, so Malika is also in rest position. But according to Shah Rukh Khan, now tree, so position of tree changes. It means now tree is in motion. So initially tree is in rest position and train is in tree is in rest position and train is in motion. But now in the new situation, train is in rest position while train is in rest while tree is in motion. Okay, so now where is the difference? So for whether this object is in rest position or in motion, so for that first we have to decide the frame of reference. Okay, so now in first case, earth is frame of reference. So according to Shah Rukh Khan, position of tree remains as it is, it means in rest position, and according to earth, position of train changes, it means train is in rest, so train is in motion. While here Shah Rukh Khan is moving with train, so there is no change in position. So here the frame of reference is not earth, frame of reference is train. Okay, so according to train, position of tree changes, it means tree is in motion. Okay, so whenever we want to decide whether the object is in motion or rest, first we have to describe the frame of reference. Or whenever we want to describe the motion of the object, okay, so first we have to identify the frame of reference. So rest and motion are relative terms. It depends upon the frame of reference. So consider another example.
A guy riding a skateboard tosses a ball up in the air. From the perspective or frame of reference of a stationary bystander, the ball appears to follow a parabolic curve. However, from the perspective or frame of reference of the guy moving on the skateboard, the ball appears to move straight up and down. In other words, two observers
So now you can see the situation.
moving with respect to one another will use.
So here motion is, okay, curved motion, here motion is straight line motion. Actually motion is motion of the ball different. It means we are watching it from different point of view. Okay, here camera is on the ground. Okay, here camera is along with this person. Okay, so it means here frame of reference is earth surface and here person himself is frame of reference. So just by changing the frame of reference, okay, motion of the object changes. Okay, so
usually disagree on the description of the motion of an object. To put it one more way, all motion is relative to the observer's viewpoint, or what we call the observer's frame of reference. Thank you very much for learning with me today. I enjoyed learning with you.
Can we please see those again?
Yeah, please. Sure. I'll add another example, dropping a ball from a moving car,
Observe.
and I'll add some music.
Till I see the day light in your arms, when your starting fires in my home.
You can see here it is curved motion, here it is straight line motion. So again, in both the case, frame of reference is different. So here we are watching from earth surface, here we are watching from the car. So car is frame of reference, here earth surface is frame of reference. It means ball is same, motion is same, but when we see it from the different angle, okay, so we have to describe the motion. So to describe the motion, first we have to decide the frame of reference.
The day light in your arms, when your starting fires in my home.
So frame of reference, so that is important concept. So whenever we want to describe the first, we have to decide frame of reference. So in physics, generally we consider coordinate system as a frame of reference. Suppose if I want to describe this box or motion of this box, okay, then I have to consider rectangular coordinate system. Okay, but if I want to describe the motion of the pen, then I have to consider, so one part is cylindrical, so circular. Okay, so I have to consider cylindrical coordinate system. But if I want to describe the motion of the mouse, okay, then it is spherical, so I need spherical coordinate system. But generally we use rectangular coordinate system. So you can see this is rectangular coordinate system. So x-axis, y-axis and z-axis, O is the intersection of all axes, that is origin. Okay, so at time t1, along with clock and this coordinate system, we consider our frame of reference. So clock is part of frame of reference. So at time t1, position of the object is x1, y1 and z1. At time t2, position of the object is x2, y2 and z. Okay, so here it is given in the textbook, so nothing new. But whenever we apply this concept in real life, then you will find the difficulty. Okay, so now tell me, what is your position? You are watching this video, okay, you are sitting on the sofa or chair. Now give me your position. So now for that, first you have to decide frame of reference, origin. Okay, so now you can consider any corner of your room, any corner of a room as a origin. Okay, identify x-axis or x-axis, y-axis and z-axis. Okay, so now your position at time, suppose here at whatever may be the time, suppose say time is 2 o'clock. Okay, so now at 2 o'clock your position. So now identify x1 coordinate, y1 coordinate and z1 coordinate. So for x1 coordinate, it means this is your origin. Identify your position along x-axis. Okay, so now you can see, so from the corner, now your position may be 3 feet or 4 feet. So x coordinate 4 feet. Now y coordinate, it means y coordinates means height, your height. So now which part we have to consider? Leg, stomach or head? Okay, it means now we have to consider ourselves as a particle, and we can consider any part of the body as a particle. So I can consider my head is our reference point. Okay, so you can consider position of the head is your position. So now position of head, so maybe 2 plus 2, 4 feet. So x coordinate 4 feet, y coordinate 4 feet. Okay, now z coordinate, it means identify your distance from the wall. So your distance from the wall may be 6 to 7 foot. So now 4, 4 and 7. So that is your position at time 2 o'clock. Okay, now at 2:30. So now at 2:30 your lecture will be over. Okay, so now you will change your position. Now consider you are at the door. So now at the door your coordinates will change. So now x coordinate, suppose you are at the middle of the door, then maybe approximately 1 to 1.5 feet. Okay, y axis, y coordinate, So initially now you are sitting, now you are stand up. Okay, it means your height will increase. So your y coordinate may be 5 to 5.5 feet. Okay, z coordinate, now you are nearer to the origin. It means z is equal to 0. So your position, okay, now your position is x1, y 5.5 and z 0. Okay. So now whenever you apply the concept, you will find difficulty. So this is visualization. So you have to whatever concept you learn, you have to apply it to the real life situation. So step by step, your imagination power will be developed. Okay. So now, what is frame of reference? A place or a situation from where an observer takes his observation is called frame of reference. So place, it means this origin, or generally we take observe the things from this point, then this point or this situation, that is called frame of reference. In the previous case, Shahrukh Khan is moving with the train, so that is the situation. Okay, so situation may be a frame of reference. So now again consider frame of reference. Now we want to decide the object is in rest position or in motion. Okay, so that now we can define it very easily. So suppose here x, y and z at time t1, x2, y2 and z2 at time t2. It means with change in the time, coordinates are also changes. Okay, so if all the three coordinates of the particle remain unchanged with time, then particle is considered at rest with respect to time in this frame. So if coordinates are changing, okay, then object is in motion. If coordinates remains the same, then object is in rest position. So if one or more coordinates of the particle changes with time, we say that particle is in motion with respect to frame. If coordinates are same, okay, then object is in rest position. So now whenever we consider change in coordinate, so it may be possible one coordinate may change, two coordinates may change, or all the coordinates may change. So if only one coordinate changes with respect to time, then motion is called one dimensional motion. Okay, so any one of the coordinate changes, then motion is called one dimensional motion. Example, motion along the straight line. So here the position of the car will change along x-axis. It means one dimensional motion. But when car take turns, it means along with x, y also changes, then motion is two dimensional motion. So motion, if two coordinates changes with time, then motion is called two-dimensional motion. So you can see motion of football. So motion of football is three-dimensional or two-dimensional. So here you can see, okay, so if we consider this path, so initial point and final point, and if we change the x and y along this, okay, so then we can say it's a two-dimensional motion. Okay, so this motion is two-dimensional motion, and we know this motion is parabolic, path is parabolic path. So here x coordinates and y coordinate both are changes, and if all the coordinates changes with respect to time, then motion is called three-dimensional motion. The motion of the insect, that is called three-dimensional. Okay, so in the next part again we will develop, or we will further discuss what is position, velocity, average velocity, change in position, distance. Okay, so that part we will discuss in the next class. Thank you very much.